This is the lesson video for 17.3 for physical science, and as always, if you want my videos all in one place, just subscribe to my channel. So today we're going to talk about the behavior of waves, like refraction, diffraction, reflection, things like that. So reflection occurs when a wave bounces off a surface that it cannot pass through. Reflection does not change the speed or frequency of the wave, but the wave can be flipped upside down. So in other words, it's going to reflect, it's going to hit a surface and bounce back. Okay, and so it's going to keep its same speed, it's going to keep its same frequency, but sometimes it can be flipped upside down. So if you look at this wave, it ends up being flipped. This would be like if you had a string attached to a wall and you're kind of doing like this. So that's an example of reflection. Refraction, on the other hand, is the bending of a wave as it enters a new medium at an angle. So in other words, let's say we have light and it's going from air to water. That would be a new medium, and so it bends as it goes through the water. That's why when you try to reach for something in the water, sometimes it's not exactly where it looks like it's going to be because the light has been refracting. When the wave enters a medium at an angle, refraction occurs because one side of the wave moves more slowly than the other. So if you look, we have this wave and it's traveling straight across. But once it starts hitting, it starts slowing down, and then that causes it to bend. So you can see it bending right here. All right, so in reflection, it's bouncing off. In refraction, it passes through that new medium. And diffraction is the bending of a wave as it moves around an obstacle or passes through a narrow opening. A wave diffracts more if its wavelength is large compared to the size of the opening or obstacle. Okay, so when you have waves coming, if they only have a small small opening to pass through, or if they're going around an obstacle, you'll see that diffraction, that bending of the waves. And here's an example where it's actually moving. It's a little harder to see though on this one. All right, so reflection is bouncing back, refraction is bending as it passes through a new medium, and diffraction is passing around something or through a narrow opening. And diffraction is greater as the wavelength is larger compared to the opening. So interference occurs when two or more waves overlap or combine. So like this right here would be interference. Two types of interference are constructive interference and destructive interference. So let's talk about what those are. Constructive interference occurs when two or more waves combine to produce a wave with a larger displacement. So if you watch, these two waves, they come together and then they get bigger as they pass through one another. That is constructive interference. So hopefully you can already figure out what destructive is. Destructive interference, on the other hand, occurs when two or more waves combine to produce a wave with a smaller displacement. So for example, these two waves, as they combine, the trough and the crest are what's going to overlap. So it actually cancels the wave out. It doesn't have to cancel it all the way out to be destructive. As long as the wave gets a little bit smaller, it's still destructive interference. So constructive, they get bigger, they kind of combine together. And destructive, it gets smaller. And then a standing wave is a wave that appears to stay in one place. Now notice it says it appears. It doesn't actually, it just appears to stay in one place. A node is a point on a standing wave that has no displacement from the rest position. An antinode is a point where a crest or trough occurs midway between two nodes. So you have your node, which is you're at your rest position, versus your antinode where you're at a crest or trough. So if you watch, these two waves, they're coming together, they're clearly both moving, but once they start overlapping, if you watch, just give it a minute, like you can still see the edges are moving, but once they completely overlap, if you look, it doesn't look like the wave's actually moving anywhere. It just kind of looks like it's doing like this. Now again, they're still technically passing one another, but we just can't tell anymore. Remember, it appears to stay in one place. Okay, but really they're just still passing one another, and so we see what looks like a wave that's just doing like this. It's not actually traveling in a direction. All right, and then here's where we look at a node versus like an antinode. So, section assessment. How is a wave changed by reflection? Well, you can say two things. The direction of the wave will change because it's going to bounce off. And then, or you could say sometimes it's flipped upside down. Okay, so the direction of the wave changes and sometimes it's flipped upside down. Number two, what causes refraction when a wave enters a medium at an angle? Well, one side of that wave is going to slow down, so that's what causes the bending. Okay, the side that enters the new medium first is going to slow down. Number three, what determines how much a wave diffracts when it enters an opening or an obstacle? The wavelength. Remember, the larger the wavelength compared to the opening, the more it's going to diffract. So what determines how much it diffracts? The wavelength. Number 4, how does the frequency of a reflected wave compare with the frequency of the incoming wave? Remember, once a wave reflects, frequency and wavelength don't change. It's just the direction of the wave, and sometimes it can be flipped upside down. So the frequencies would be the same. The frequencies would be the same. All right, number 5. What is the amplitude of a wave that results when two identical waves interfere constructively? Well, if two waves are identical, that means they have the same crest. If they interfere constructively, that means they're going to add together. So the amplitude would double. Since we don't know the number for the amplitude, we can't say a number, but we can just say the amplitude would double because the two crests would add together to be double what they were originally. All right, and that was it. I thought there was going to be another slide. All right, so hopefully you understand a little better about reflection, refraction, diffraction, standing waves, and interference.